Hello everyone, the channel's not dead. After Economics Paper 2 for Cambridge, I can finally say that I've been liberated of anything except multiple choice papers, which are, of course, just multiple choice papers. So I have a lot more free time to make these videos in between now and the time at which everyone will be taking the Edexcel for the pure IGCSE math exam. So we're going to jump right into the deep end with this heinously long question, which ends in this ridiculous integration of some binomial expansion for this bracketed term here. So first of all, it says expand this expansion up to x cubed, and then this expansion up to x cubed, and the first thing you might notice is that this is a minus while this is a plus, and this is a plus while this is a minus. So these terms are actually going to be very similar. And then write down the range and values of x for which both your expansions are valid. So obviously this is going to be the kind of thing where you got to use the rule that absolute value of x got to be less than 1 if you're using the expansion 1 plus x to the power of n. And finally it says expand 4 minus 3x over 4 plus 3x to 1 over 3 to the power of 1 over 3 and extending powers of x up to and including the term in x cubed. Now if you look at this and then you look at this, you might notice the numbers here are very similar. And given that one of these is a positive and one of these is a negative 1 over 3, it's probably going to be pretty clear that probably something like you divide this by this to get this term, because it looks like a fraction on top where you have the minus sign on the top and the plus sign on the bottom. And in actual fact, when you expand this by changing the 1 to a 4 over 4, you get 4 minus 3x over 4 and 4 plus 3x over 4. So clearly if you divide this by this, you'll get this, which is why I think you may actually be able to do this. Or since this is a negative 1 over 3, in actual fact you multiply this by this to get this, because as it's the denominator, it will be represented by a negative exponent anyway. Alright, so that's the game plan for this. So firstly, it says expand 1 minus 3x over 4 to the power of 1 over 3 in ascending powers of x up to and including the term in x cubed. Now for this, you're going to want to use the irrational, or the infinitely adding up binomial series, which is the 1 plus x to the power of n is equal to 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 divided by 3 factorial x cubed plus dot dot dot. I'm not sure if the mark scheme generally requires you to have this, but I recommend you would, because it demonstrates your understanding that this is an infinite series and you're only calculating it up to a certain degree of accuracy, which is this x cubed term here. So anyway, when we look back at this expression here, clearly this is not a 1 plus x, this is a 1 minus 3x over 4. So what we do here is we substitute x to be minus 3x over 4. So clearly, if we substitute x to minus 3x over 4 on this side, the expansion must be where x has been substituted to minus 3x over 4 on this side. So we end up with something like 1 plus, or there's not a plus, 1 minus 3x over 4 to the power of 1/3 is equal to 1 plus n, well, is 1 over 3, and x would be minus 3x over 4. So 1 divided by 3 times minus 3 divided by 4 is going to be minus 0.25, or minus 1 over 4. So in actual fact, there's not a plus sign, there's a minus sign. 1 minus x over 4. And secondly, we have n times n minus 1 over 2. So n would be 1 over 3 times n minus 1, which would be negative 2 over 3, divided by 2 factorial. And 2 factorial will be just 2 times 1, and then you stop. So 2 factorial is just 2 divided by 2 to get that the value of this must be, or the value of this coefficient at least, is going to be minus 1 over 9. And then on this side here, the x squared, you have got to multiply this 1 over 9, or this minus 1 over 9, by minus 3 over 4 squared. And eventually, I'm pretty sure this is going to work out to minus 1 over 16. So the coefficient of this x squared term is going to be minus 1 over 16. So minus x squared divided by 16. And then finally, plus n times n minus 1 times n minus 2 divided by 3 factorial, which is just 3 times 2 times 1, which is 6. So you have 1 divided by 3 multiplied by minus 2 divided by 3 multiplied by minus 5 divided by 3, because minus 2 over 3 minus 1, it goes to minus 5 over 3, nothing else. And you get 10 divided by 27, and a positive 10 divided by 27, since this term is negative and this term is negative, and they cancel out. And anyway, you've got to divide this by 6 to get your 5 over 81, and then there's the x cubed term here to worry about. So it's 5 over 81 multiplied by minus 3 over 4 cubed to get negative 5 over 192. So ultimately, you know that the coefficient of the x cubed term is going to be negative 5 over 192. Now, if you are a bit confused as to what is happening in this madness of different coefficients multiplying together, you can essentially say that because we are using this formula, this x term has been substituted completely by this expression. So this expression goes into this x, it goes into this x, and it goes into this x. And what happens when this goes into this x? The coefficient of x here, namely the minus 3 over 4, gets the same treatment of the exponent as the x it's replacing. So like here it's just x by itself, no power, so it's minus 3 over 4. And for example here, x cubed, since it's this entire expression cubed, the minus 3 over 4 is going to be cubed as well as the x is going to be cubed. And that's why we get the x cubed that we add on at the end, and that's why we need to take in minus 3 over 4 cubed into account when we are calculating the final coefficient of the expression. So anyway, we have come up with this expression here, and of course there's a plus dot dot dot. We can put a box around this as our answer. Obviously, when you're doing this in the exam, you're going to want to make somewhat neater boxes. Anyway, we have this expression here, expand 1 plus 3x divided by 4 to the power of negative 1 over 3 in ascending powers of x up into and including the term in x cubed, simplifying in terms as far as possible. So this is a routine which is very similar to the previous one. So instead of 1 minus 3x over 4, we have 1 plus 3x over 4 to the power of negative 1 over 3. So it's going to be equal to 1, and then in this case the nx term, n is negative 1 over 3, x is 3x over 4, and we get the same minus x over 4 term right here. And secondly, we have minus x squared over 16 here, but it's actually going to be different because minus 1 over 3, you take away 1, it goes to minus 4 over 3, not minus 2 over 3, and that can actually create somewhat of a difficulty when you're trying to compare these two expressions together, because even though they look suspiciously similar, their expansions are not going to be very similar at all. So you have n times n minus 1, which would be minus 1 over 3 times minus 4 over 3, which brings you to positive 4 over 9. And then of course divide by 2, you get positive 2 over 9. Then multiply by x squared. And your x squared is going to be 3 over 4 squared times x squared. 3 over 4 squared is 9 over 16, so you multiply 2 over 9 by 9 over 16. Of course the 9 cancels out, and you're left with positive 1 over 8. So this next term is plus 1 over 8 x squared. Or I could have written this as x squared over 8, but well, I'm seeing the coefficient on the calculator screen as the number 1 over 8 by itself. I guess that's why I instinctually wrote it that way. And again, it's the same routine for the third term of the series. N times n minus 1 times n minus 2 would be minus 1 over 3 multiplied by minus 4 over 3 multiplied by minus 7 over 3, which is evaluated to minus 28 over 27, which is just below negative 1. And then you multiply this by 3 over 4 cubed, because 3x over 4 cubed is going to be 3 over 4 cubed times x cubed. So multiplied by 3 divided by 4 to the power of 3 on this calculator, and you get the result minus 7 over 16. And of course, one thing I realized I've forgotten to hold into account is this divided by 3 factorial. It is absolutely imperative that you do not forget this, because it's quite an important part of the expansion. Anyway, I did not take that into account in this term. I did take it into account in the previous term, looking through the calculation log. So you divide you divide minus 7 over 16 by 6 again in order to get your final coefficient of minus 7 over 96. And of course it's plus dot dot dot, because this is an infinite series. So these two tasks are extremely tedious, and this is why I generally, personally, do not like these kind of questions where they ask you to expand some ridiculous expression, but such is life, and it is a part of mathematics that we will just have to deal with. So it's useful to know how to do this anyway. Write down the range of values of x for which both of your expansions are valid. So, like I said, when you're using this expansion method, 1 plus x to the power of n, where you get an infinite series, it only works if the absolute value of x is less than 1. Because if it was more than positive 1, then you'd get something like 2 to the power of n, which would eventually spiral or be uncalculable by this metric. And on the other hand, if it is 0 or less, then you may not get a converging series in the end. Like, basically, I think it's something to do with how the expansion will either converge to a certain number or continue on to infinity, depending on the number that's in this x. It's a pretty interesting topic, and I might make a video on it later, but not going to deal with it now. We're just going to use our substitution that we substituted x as, well, in one case we substituted it to be negative 3x over 4 and plus 3x over 4. So we'll just put plus or minus 3x over 4, since it's asking us the range for which both of our expressions are valid. So that means, of course, the absolute value of x is equal to the absolute value of plus or minus 3x over 4, which obviously, because the absolute value gets rid of any sign, it's just looking for this part of the number here, basically the distance from 0 of this number on the number line. The absolute value is going to be 3x over 4. And since absolute value of x got to be less than 1, this inequality is equivalent to this, which if you multiply by 4 over 3, you'll get rid of this 3 over 4 sign here, and you'll find the actual range of values of x. And of course, this is the outcome. Absolute value of x is going to be less than 4 over 3. And you can test this as well, because if you put 4 over 3 into x here, you will get 1 for both of these, and that's of course the limit that we are going to push this expression to. We're not going to have it be 1 or greater. So if you put something, for example, slightly less than 4/3, you get a number that's almost 1. And you can see how the expression plays out. Finally, or not finally, in fact, there's one more question, but expand 4 minus 3x over 4 plus 3x to the power of 1/3 in ascending powers of x up to and including the term in x cubed, simplifying your terms as far as possible. Now this is going to have to use the observations that I made earlier in the question, which was that it very much seems like we're just going to have to multiply these two expressions together. So let's confirm this by manipulating them a bit. We know the first expression, 1 minus 3x over 4 to the power of 1/3 is going to be equal to 4 minus 3x over 4 to the power of 1/3. And additionally, 1 plus 3x over 4 to the power of negative 1/3. If we substitute this 1 by 4/4, which is what we did here, we will get that this is equivalent to 4 plus 3x over 4 to the negative 1/3. And since this is a negative sign, you can say actually, well, this is 1 over 4 plus 3x divided by 4 to the power of positive 1/3. So you may be noticing something here. If we were to multiply the two expressions together, we would get something, or a rather large fraction, which looks like this: 4 minus 3x over 4 to the 1/3 divided by 4 plus 3x to the 4 divided by 4 to the 1/3. And anyway, because of, or you may remember this from your indices properties from chapter 1 of Photopure, that this is equivalent to the entire fraction being to the power of 1/3 of 4 minus 3x over 4 divided by 4 plus 3x over 4. And these divided by 4's cancel out. If you have the same denominator, they cancel out. And if you have the same numerator, they cancel out. So you can cancel out between this one and this one, and between this one and this one. That's what happens when you have a fraction divided by another fraction. Anyway, that's how we know that multiplying the two expressions together will give us the expression we want. Because if you disregard the 4's, because we've just cancelled them out, we have this exact expression, 4 minus 3x over 4 plus 3x to the power of 1/3, which is, in fact, the expression we want. So, evaluating this calculation, in which we have multiplied the two together, will require us to go through these and figure out the combinations of the elements of the brackets that will give us powers less than 1/3. For example, to get x to the 0 power is just going to be this 1 times 1. To get x to the first power, it's going to be this 1 times this 1, as well as this 1 times this 1. To get x to the 1th power, x to the 2nd power, it'll be the x to the 1 times x to the 1, as well as x to the 0 times x to the 2, and the other way around. And finally, to get x to the 3rd power will be quite a nightmare, because we will have to, or actually no, it won't be so bad, but there'll be 4 combinations basically. This 1 times this 1, because it's x to the 1 times x to the 2, this 1 times this 1 because of the same logic, and also x to the 0 times x to the 3, as well as x to the 0 times x to the 3 in this direction. Anyway, we can write out the brackets that we're going to be evaluating just to make the calculations clearer for ourselves. So it's 1 minus x over 4 minus x squared over 16 minus 5x cubed over 192. We just write it out here. multiplied by 1, again, minus x over 4 plus 1 over 8x squared. This time I'm actually going to write it in this form, x squared over 8 and minus 7x cubed over 96 is going to be our final term in this series. Okay, so firstly, multiplying them together, we have the x to 0 terms. I suggest it would be best for you to organize your working like this, because when you get to higher and higher term numbers, it would be more and more ridiculous. So x to the 0 terms is going to be 1 times 1 is equal to 1. X to the 1 terms, this is going to include the one from this expression times x to the 1 term from this expression. So 1 times minus x over 4 is equal to minus x over 4. And then secondly, the one from this bracket multiplied by the minus x over 4 from this bracket. So you get 1 times minus x over 4 is going to be equal to minus x over 4 again. You add them up, and you'll get that the x to the 1 term is minus x over 2, it simplifies to. And then next you have your x squared terms. So firstly, you'll get the x to the 0 term times the x squared term here. So 1 times x squared over 8 equals, of course, positive x squared over 8. And then secondly, you have your minus x over 4 multiplied by the minus x over 4 here. So that's not a 1 times minus x over 4. It should be x over 4 multiplied by another x over 4, because you're taking the x to the 1 term here and the x to the 1 term here. You multiply them together, you get the x to the 2 term that you want, which is going to be positive x squared over 16. And finally, the third term is going to be, well, we had this 1 times the x2 term here, this 1 times the x1 term here, and finally this 1 times the x0 term here, which is going to be 1. So minus x squared divided by 16 times 1, of course, is going to be minus x squared divided by 16. So of course these two terms cancel each other out when you're adding them up, and you're left with just x squared over 8. And finally, we'll have to jump onto a new page for these x cubed terms. But anyway, first we have 1 multiplied by minus 7 over 96 x cubed. And then we also have minus x over 4 multiplied by positive x squared over 8. So minus x cubed over 16. And then we have this x squared over 16. Well, we've gotten this one, and then minus x squared over 16 times minus x over 4, which is going to be positive x squared over 64. Or actually, yes, no, we've made a calculation error. This should be x over 4, not 2. And this is going to give us minus x cubed over 32. And the minus x squared here, minus x squared over 16, you multiply it by minus x over 4, is going to give us the positive x cubed over 64. So bear with me while I write this all out. And finally we arrive at the concluding term, which would be minus 5x cubed over 192 times by the 1 in the next bracket. And when we add them all up, not gonna lie to you guys, I've been doing most of this adding up and multiplying on a calculator because my brain is just pooped from the exam today. So, oh dear, the buttons on my calculator aren't working. This ain't good. Alright, we are in business. Minus 7 divided by 96 plus minus 1 over 32 plus 1 over 64 plus minus 5 over 192. And we end up with the number minus 11 over 96. So ultimately, after summing up the terms we get from multiplying these two brackets out, we get that the expansion of 4 minus 3x over 4 plus 3x to the power of 1/3 is going to be equal to this 1 minus x over 2 plus x squared over 8 minus 11 over 96 x cubed. Alright, so we can box that. That is our answer for part D. And finally, it's been 27 minutes on this question. That's quite a long time. I'm quite rusty at this. Anyway, hence obtain and estimate 3 significant figures of this integral from 0 to 0.5. Right, so hopefully you guys remember how to do your definite integration within limits, because this is a plus dot dot dot. When you're integrating it, you can ignore integrating the plus dot 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 dot, because if it's insignificant here, it will be insignificant in your integral. Like, that's probably not the case if you go up to do more and more mathematics, but it works here, and I'm just going to leave it at that. Anyway, we have the integral, my favorite symbol. I like to call it the ligma, for reasons I will explain in a video when I talk about calculus for a long time. Anyway, integral from 0 to 0.5 of 1 minus x over 2 plus x squared divided by 8 minus 11 over 96 x cubed plus dot 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 dx. Right, so this is just going to be some pretty basic power rule integration. So it will be the bounds of, well, 1 just goes to x, minus x over 2, well, that would be minus x squared over 4, because you bring the 2 down, you multiply by the 1 over 4, you get 1 over 2. And then plus x squared over 8, that would be plus x cubed over 24. In case you don't see what I'm doing, I'm adding 1 to this number and dividing the coefficient by it, because if you differentiate, it will go in reverse. X cubed, the 3 minus 1, the 3 is multiplied by the 1 over 24, and then 1 is subtracted. That's how you get from here to here. Basically, if you know the integration power rule, you should be able to do this entire integral flawlessly. And finally, 11 over 96x cubed. Of course, it's going to be dividing 11 over 96 by 4, which will give you 11 over 384, x to the power of 4. from 0 to 0.5. Now, firstly, because this is a definite integral, you do not have to have the plus c. And again, I will explain this in a later video. I'm planning to make a video about calculus because there's a lot of intuition about it that would be extremely useful for people to understand, but no one bothers to actually teach it in school. So be ready. Anyway, because this is a 0 and all these terms here are multiplied by x, if x is 0, all these terms are going to go to 0. So you can just put a minus 0 on the end here, which is what happens when you evaluate your lower bound. And for the 0.5 here, it's going to be 0.5 minus 0.5 squared over 4. And you might be wondering, why are we doing this to 0.5 and not 1 over 2? Well, the thing is, this bounds are not perfectly precise. It's not going to be the case that you get a perfectly precise answer, and so we cannot generally do our working in fractions for this kind of thing. So you have 0.5 minus 0.5 squared over 4 plus 0.5 cubed over 24 minus 11 over 384 times 0.5 to the power of 4 minus 0. Anyway, at this point, all you need to do is plug these numbers into your calculator and you will be good to go, having evaluated the value of this integral. So 0.5 minus, and then the fraction symbol, 0.5 close bracket power of 2 divided by 4 plus fraction symbol 0.5 close bracket power of 3 divided by 24 minus fraction symbol 11 on top, 384 on the bottom. Move the cursor of the calculator back to the top, then open bracket 0.5 close bracket power symbol 4 to get your expression for this fraction. And we get a sum which is 0.440917,688. Now that's quite the mouthful to write down on the calculator. Normally in the more modern exams, it will tell you to how many significant figures. Yes, it does tell us here. So it's an estimate to 3 significant figures. So what we would do is we would write that this is in fact equal to 0.4409179688. That's just all the calculator digits I have on my display, and which would be equal to 0.44123 significant figures. Now, unfortunately, due to the technical limitations of Microsoft Edge, which I'm using to actually record all the writing, I can't have 2 documents open at once. So at this moment, when I'm just using the past papers off the internet, the mark schemes are not attached to them, of course, because they're question papers. So this means I can't actually check the question against the mark scheme. So in this video, I'd like to send out a warning that if I've made any arithmetic errors, please tell me in the comments and inform others that this video may not have the correct end result. But I assure you that all the working methods and intuition behind what I'm doing in this answer should be valid for the purposes of understanding how to do the question. Alright, so with that being said, I'm going to conclude this video right here. Thank you for watching if you've watched to the end, and I'll see you guys next time.